Hey class, Mr. Hanji here. Today we are going to be taking a look at section 1.1, which is going to deal with solving equations. Now, section 1.1 is going to be our introduction into Algebra 1A. And really what this section is a review back to stuff that you have seen before in pre-algebra. It's just a way to refresh and to remember and talk about the different ways that we have solved equations, and just to kind of give you some more practice before we move forward in Algebra 1. So, with that said, we have one learning goal for today. So our learning goal for today is that you will be able to solve 1- and 2-step equations. So our first example is going to deal with solving 1-step equations, and our second example is going to deal with 2-step. Now, before we jump into some actual solving, we're just going to kind of do some recollection and talk about a few things. So the first thing that we are going to talk about is that an equation, so that's going to be our first term for today. An equation is a mathematical sentence that uses the equal sign to show that two expressions are equivalent. Now, expressions can be numbers, variables, constants, which are just letters, say like A, B, C, X, Y, Z, or combinations thereof. So, an expression, for example, would be something like 2x. Okay, so an expression is just some sort of mathematical sentence. Another example of an expression can be y plus 3, and so on. Now, to make it an equation, you have to have an equal sign between two expressions. And that's what we're going to go through and solve today. Now, the solution of an equation is the value for the variable that makes the equation true. So if we have something like x plus 2 equals 4, okay, the solution to this equation is what's going to be the value of x. So what plus 2 then equals 4? Okay, and so to determine that, we are going to use properties of equality. Now, in some cases, you could look at an equation and think in your head about what the answer should be and come up with the correct answer. But as we move further in math, there are going to be cases where you cannot do that in your head, and it's going to require solving. So while part of the problems today are simple one-step solving, that you may not have to do properties of equality to solve it, really what we're trying to build today is a pattern and a learned habit, so that way when we add on 5 different steps, you know what you need to do when you get to that point. So, I've mentioned these properties of equality, so let's go ahead and take a look at them. We're going to take a look at all of them at once, just to get a view, and that way we can talk about all of them fairly quickly. So, properties of equality. We have addition property of equality, where it states that you can add the same number to both sides of an equation, and the statement is true. So, if I add 2 to 3, and I add 2 to 3 as well, 3 plus 2 is 5, and then we get 5 as well. Same can be said with algebra. If I add c to both sides, I still have the same statement that is true. What all of these state is that I can add to both sides, I can subtract to both sides, I can multiply to both sides, and I can divide to both sides, and the statement will still be true, as long as it is the same number. So you have to add the same number, subtract the same number, multiply by the same number, and also divide by the same number. Okay? As long as you do that, you add or subtract, multiply, or divide to both sides, then you are okay. Now, in terms of properties of equality, I'm not going to ask you to memorize these. You're not going to have to really go through and memorize them and then apply them on a quiz. really it would just be reference. And really it's just, hey, you're saying you add it to both sides, but a little more fancy. All right, so with that said, let's go ahead and get into our first example. So we're going to go ahead and slide this up. And let's talk about example 1a first. So example 1a states x minus 17 equals 53. Now, some of you could sit there and figure out, just by process of elimination, of what number minus 17 equals 53. Bravo, and perhaps see if you can figure it out. But to take away that guess and check, we're going to go through and use a process that gives us the right answer. So whenever I'm solving equations, I usually like to ask myself, what is happening to the variable? Okay, in this case, x is our variable. So what is happening to it? We have x minus 17, so x is being subtracted by 17. Remember, to solve equations, you have to undo what is happening to x. So if we are subtracting by 17, it means you have to undo subtraction. So what is the opposite of subtraction? It's addition. So if I'm solving for x here, okay, so that's my goal, I need to undo what's happening to it. That means I'm going to add 17 to both sides of the equal sign. If it helps you to keep track of both sides, you can draw a line down the equal sign, but know that it is not required. So, when I go through and add 17 to both sides, okay, negative 17 plus 17 is going to cancel out, and we are left with x equals. Now, again, if you can go through and do 53 plus 17 in your head, or by taking a little bit of time, by all means, that is quite all right. Do not feel bad about using a calculator. Calculators are okay, and it's not something I'm going to tell you not to use. In fact, it's something I'm going to suggest you get used to and comfortable using. So if we do 53 plus 17, we then end up with 70 as our value for x. So then we get x to equal 70 as our answer. So x equals 70 is the answer for this, and if they want you to go back through and check your answer, that just means we're going to take what we found for x and we're going to plug it back in. So if I do 70 minus 17, when I hit enter, I should end up with 53, and in this case, I do. So x equals 70 is in fact my answer in this case. Alright, next let's take a look at example 1b. So example 1b is x plus 8 equals 34. So what is happening to x? It is being added by 8. So the opposite of addition is subtraction. So if I'm adding 8, that means I need to end up subtracting 8 to both sides. So if I subtract 8 to both sides, the 8 is going to cancel on the left, and then I'm going to end up with x equals, and again, if you want to use your handy dandy calculator, we do 34 minus 8, and we are going to end up with x equaling 26 as our answer. Now, if we want to double check, if I did 26 plus 8, we would in fact end up with 34. So, x equals 26 is the correct answer. Alright, let's take a look at examples 1c and 1d. So if we look at example C, we have 3x equals 54. So, just a quick recollection for you and a little memory jogging for you. Whenever you see something like 3x here, okay, there's no sign in between 3 and x. So what that means, or what it implies, is that we are multiplying. So we're doing 3 times x. So whatever number I'd plug in for x, let's say 2, it would be 3 times 2. So whenever you see a number and a variable attached, that means that they're multiplying. So if we have 3x, that means 3 times x. So the opposite of multiplying is dividing. So that means that we're going to divide 3 to both sides. So the 3's cancel, and we're left with x equals. And then if we go through and do 54 divided by 3, we end up with 18. As our answer. So x equals 18 is going to be the solution to this equation. Because if you do 3 times 18, you will end up with 54. All right, let's take a look at D now. So for D, we have x over 7 is going to equal 28. Whenever you see a fraction, know and remember that a fraction implies division. Okay, so what this means is x is being divided by 7. So x over 7 implies division. So the opposite of division is multiplication. So what you are going to go through and do to be able to solve this is you're going to multiply by what is ever on the denominator, which means the bottom number. You're going to take this number and multiply it to both sides. What that does is cancel out your fraction. So in this case, we're going to multiply 7 to both sides. So when I multiply 7 to both sides, the 7's cancel out and my fraction goes away. And I now have 28 times 7. So if I do 28 times 7, we end up with 196 as our answer. And if you want to double check that, we just do 196 divided by 7, and we end up with 28 as our answer. Therefore, x does in fact equal 196. So that is example 1, and that is going through and solving equations using one step. With example 2, we're going to go through and solve equations using 2 steps, meaning we're not just adding, subtracting, multiplying, and dividing, yet we're going to add or subtract and then multiply or divide. So it's going to involve 2 steps for each problem to solve. All right, so let's take a look at example 2. So example 2 is going to ask us to do the same thing, to use the properties of equality to go through and solve. If we look at example 2a, example 2a says 3x minus 2 equals 61. So let's ask ourselves what is happening to x. It's being multiplied by 3, and it's being subtracted by 2. Now, think back to when you talked about solving equations before in math class. Okay, there is an order that you need to go through and do things. Okay, we need to do reverse order of operations. So if order of operations was PEMDAS, where you would do parentheses, exponents, multiply, divide, add, subtract. Instead of going that order, we need to go in reverse. So we're going to add or subtract, multiply or divide, and then deal with the exponents and parentheses last. So adding and subtracting is going to be your first step. Because I have minus 2 here, the opposite or the inverse of subtracting 2 is going to be adding 2. So if the opposite or the inverse of subtracting is addition, means we add 2. Now, quick note, do not add 2 to this as well, as you only have to do it once to each side. So do not add 2 to every single part, just add it to one part. So if I go through and add 2, because these are like terms, they cancel out, I end up with 3x equals, and then if we do 61 plus 2, we end up with 63 as our answer. So I now have 3x equals 63. That is not my final answer, so we need to go through and take this another step further. I have 3x, and like we talked about before, 3x implies multiplication. So the opposite of multiplication is going to be division. So we're going to divide 3 to both sides. So when I divide 3 to both sides, it cancels out on the left side. And if I do 63 divide by 3, we end up with 21 as our answer. So in this case, x equals 21. Now, if you want to double check it, we're going to plug 21 back in for x. So we're going to have 3 times 21 minus 2, and we end up with 61 as our answer. All right, next let's take a look at example 2b. So example 2b states x over 2 plus 4 equals 10. So again, if I'm doing reverse order of operations, okay, I need to add or subtract first. Because we have plus 4, that means I need to do the inverse of addition, which the opposite of addition is going to be subtraction. So we're going to subtract 4 to both sides. When I do that, we end up with x over 2 is going to equal 6, because 10 minus 4 is 6. Alright, so now I have x over 2 equals 6. That is not my final answer because there's something still attached to x. To get x alone, because we have a fraction, remember that a fraction implies division. So the opposite of division, in this case, is multiplication. So the inverse of division is multiplying. And again, because 2 is my number on the denominator, that is the number that I'm going to multiply to both sides. Whenever you see a fraction, you're going to multiply by what's on the denominator. So if I multiply 2 to both sides, 2's cancel out, and I end up with x equaling 6 times 2 is going to be 12. And if you want to run through a check on your calculator for this, if I go through and do 12 divide by 2 and then plus 4, I end up with 10 as my answer. Alright, so that is example 2a and b. Now, I have 4 more different examples under example 2. I am not going to go through and run through all 4 of them for a matter of time. I don't want to keep you sitting here watching as I run through 4 more examples. Okay, so I will leave parts C, D, E, and F for you to run through. If you have any questions about C, D, E, or F, be sure to ask me the next time you see me, and I'll be more than happy to run through them or answer any questions that you might have. You can also check the completed notes for how I've run through and done those problems. And if you have a question about what I did, just let me know and I'll be more than happy to answer. Now, before we jump into our third and final example, I do want to highlight F real quick. So if we go all the way up to f here, so for f, it is 8x minus 14 over 10 equals 5. Now, this is what I call a problem with a giant fraction, because there's one whole fraction on a side. Yes, there's subtraction here. And reverse order of operations would tell us that we need to undo the subtraction, but it's locked in a giant fraction, meaning I cannot really add 14 to both sides yet. Okay, because we have one whole fraction here. You have to undo the fraction first before you can go through and add 14. So what you would do is, because we have a fraction that implies division, it means you have to multiply by what's on the bottom first. So we're going to multiply 10 to both sides. And what you get is 8x minus 14 is going to equal 50. So 8x minus 14 equals 50. That then should look more what you're used to, and you should be able to go through and solve from there. So I'm going to leave that there. If you want to go through and finish, by all means go ahead and finish on your own. I am not going to run through that right now. All right, example 3 is going to be our story problems for today. Because we cannot avoid story problems, we need to go through and address it and talk about them. So let's take a look at example 3a first. So example 3a states this. In 1963, Dr. Martin Luther King Jr. began his famous I Have a Dream speech with the words, 50 years ago, a great American in whose symbolic shadow we stand, signed the Emancipation Proclamation. The proclamation was signed by President Abraham Lincoln in 1863. But how long is a score? We can use algebra to go through and find out the answer. So, few things. Anytime that you see numbers involved, okay, because we're talking about math, that's generally a pretty good indicator and something we should highlight. So we see 1963 and 1863. But there is another number here when we talk about 50 years ago. So that is the other place that a number comes involved. So in 1963, he stated 50 years ago. So 50 years ago is referring to 1863. So if he stated this in 1963 and he's referring to 1863, we need to figure out the difference between these years. So we're going to do 1963 minus 1863. Oh, I forgot the 6. 1963 minus 1863, and we get 100. So what Martin Luther King Jr. is referring to is a time period of 100 years. So when we're talking about 50 years ago, okay, let's have x refer to number of years in a score. So if he said 50 years ago, which we're referring to 100 years, we would end up with 5x equals 100. And then all we have to do is go through and solve. Now, based off of what we have talked about before, okay, when we have something like 5x, that implies 5 times x. So the opposite of multiplying is dividing. So if I go through and divide 5 to both sides, if I do 100 divided by 5, we get 20 as our answer. So there are 20 years and a score. So, whenever you are in history class and you happen to come across any documents that talk about a score, like 5 score with his I Have a Dream speech, or Abraham Lincoln's speech talked about 4 score and 7 years ago, a score means 20 years. All right. Now, to give you one more example, just for matter of reference, let's take a look at B here, just to give you another exposure to story problem and give you another problem to reference. I will leave the solving to you, but we'll go through and set it up together. So, for part B, it talks about an emu who measures 60 inches in height is 70 inches less than 5 times the height of a cockapoo. And it wants to know what is the height of a cockapoo in inches. So, as I mentioned, let's go through and highlight the numbers that they give us. So we have 60 inches in height is an emu, and it is 70 inches less than 5 times the height of a cockapoo. So, few different things to note in terms of terminology. This word is right here is super important. Is means that they are equal. So, what it means is that an emu that measures 60 inches in height equals 70 inches less than 5 times the height of a cockapoo. So, is, whenever you're dealing with a story problem, generally indicates that we're talking about them being equal. Now, we have 2 different things we're talking about here. We're talking about an emu and a cockapoo, and we are comparing their heights. So, we know that an emu measures 60 inches in height. So, we know that an emu equals 60 inches. And we know that cockapoo is 70 inches less than 5 times the height of a cockapoo. So, we're going to refer to the height of a cockapoo as K. And then we need to go through and set up the equation. So, I already know that an emu is 60 inches, and we have already established we're equaling the heights. So 70 inches less than 5 times the height. Less than implies subtraction, times implies multiplication. Now, less than does not mean we're doing 70 minus 5 times the cockapoo height. What it means is that we're going to take 5 times the height of the cockapoo, so 5K, and less than that, 70 inches. So we end up with 60 equals 5K minus 70, and then that is our equation to go through and solve. I will leave that for you to solve if you would like some extra solving practice. If you are stuck on the equation, be sure to just ask for help, and I'll be more than happy to answer however I can. So, that is our notes for today for section 1.1, dealing with solving equations. We've taken a look at 1-step solving, 2-step solving, and then a couple story problems. Your homework is going to reflect this. If you have any questions regarding what we talked about today through this video, be sure to ask, and I'll be more than happy to answer. If you need any help with your homework, reach out, and again, I'll be more than happy to help you. Well, I hope this has been helpful for you and that you have learned something today. But that is all that I have for you guys today, and that is section 1.1. Have a great day. Bye.